Rigidoporus microporus is a well-known fungal pathogen causing white-root disease on more than 100 different tree species. The greatest loss caused by this pathogen was recorded in rubber tree plantation. This disease is one of the most detrimental diseases in rubber plantation in Indonesia, India, Malaysia, Sri Lanka, Thailand, West and Central Africa. It has been reported to cause about 3 to 15% of loss on production every year, particularly in smallholder plantation. The pathogen is responsible for white root rot disease, infecting the host root via white fibrous mycelia, causing vascular dysfunction and visible symptoms including leaf discoloration and dieback in severely infected trees.
Hello, my name is Emmanuel and my metric number is BF22110166. I will presenting the inoculation and the penetration of white root rot or Rigidoporus microporus. So during inoculation, the spores or fungus structures from Rigidoporus microporus will come into contact with the healthy tree roots. And there are several ways or methods on how the inoculation can occur. The first one is direct contact between infected and healthy roots. As the fungus colonize the root system of an infected tree, its mycelia can grow and extend outwards, and eventually reaching and making contact with the roots of nearby healthy trees. The second one is contaminated soil. This will occur when new trees are planted in areas with this contaminated soil. The fungus readily comes into contact with the developing root systems and initiating the infection. And the third one is water flow. Spores can be carried through the soil by water movement. The fungal travel further distance and reach healthy trees that are not in direct contact with the infected ones. For penetration, penetration will occur once the fungus makes contact with the healthy root. For penetration, there are few steps on how the fungal can penetrate the root structure. The first step is enzyme secretion. The Rigidoporus microporus produces specialized enzymes called cellulases and ligninases. These enzymes break down the complex cellulose and lignin that make up the root cell wall. This weakens the root structural and creates opening for the fungus to penetrate. And the second step is fungal hyphae. The thread-like structure that make up vegetative body of the fungus can readily penetrate the root. This hyphae then grow and branch within the root tissue, gaining access to vital nutrients and water. So that's all from me. Thank you.
Good evening. I will discuss my part, which is infection and invasion. The fungal infection caused by Rigidoporus microporus, this pathogen is responsible for devastating root diseases leading to severe damage in rubber plantation. Infection process. The infection begins primarily through contact between infected stems or root debris and healthy rubber tree roots. This often occurs during land preparation or replanting. When healthy roots come into contact with infected material, the fungal spores of Rigidoporus microporus germinate and invade the root tissue. Fungal invasion. Once the root tissue, the fungus grow as white fluffy mycelium. This mycelium breaks down lignin and cellulose, leading to root decay. Additionally, the fungus forms thick white strands called rhizomops, which spread through the root system, infecting other parts of the tree. As the fungus spread, it causes several symptoms in rubber tree, which is yellowing or reddish-brown leaves, which is infected trees often exhibit discolor leaves. Second, premature flowering. The stress caused by the infection can lead to early flowering. And last is dieback. This refers to the gradual death of the trees from the tips of the branches downward.
So I will continue with the dissemination. The fungus primarily spread through the soil-borne mechanism. The fungus can also be disseminated through infected plant sprays, such as fallen branches, leaves, or roots. Other than that, the fungus can be spread by the water and irrigation. Surface water and irrigation practices can contribute to the spread of the fungus within and between plantation and orchard. For the survivor, the fungus can be survived for extended period in soil even in the absence of the host plant. The fungus form resilient structures such as a survivor structure or mycelial mat that enable it to persist between host plantings. Other than that, infected roots or plant debris serve as reservoirs of the fungus. There is another factor that fungus can be survived because of the environmental conditions. The fungus thrives in warm and humid environments typical of tropical and subtropical regions. These conditions support fungus growth and enable its survival in the soil and on the plant material.
The first strategy is precaution to be taken during uprooting the old span and land preparation. Before uprooting, demarcate all the infected patches using natural boundaries such as rocks. Remove all infected roots as much as possible, particularly from the trees bordering the patch, and remove them from the field. Do not cut large laterals to facilitate uprooting trees. Never roll infected stumps to lower slope as it introduces the pathogen to areas that free of disease. Next is precaution to be taken during replanting. Change the planting points and the interrow distance between replanting cycles. This helps to reduce the incidence of the disease as it will take a longer time for roots of new plants to contact the old infected roots. Then, keep the rubber well away from the best of rubber plants. Lastly, precaution to be taken after replanting. Rubber plants established within previously infected rusty areas should be inspected frequently by exposing roots and observing foliar symptoms. Apply immediately a fungicide for infected plants. Infected plants that having more than 50% of dead color should be uprooted and remove the infected debris, including the source of infection. For no reason, the infected logs or root debris should be left in the field since the cover crop and the adjoining healthy trees can also be infected in contact with such debris.